In today's lesson, we're going to begin looking at our polynomial operations. You began looking at polynomials last year in grade 9, and we're going to continue and review a bit today and make sure we're all caught up before we move into the next level of polynomials. So first off, let's make sure we understand a few vocabulary words. So 6x I call a term. 5a squared is another term. These are terms because they are numbers and variables that are being multiplied and or divided together. Just like xy is a term, xy divided by 7 is a term. So whenever you multiply, divide numbers with variables, you get a term. Sometimes your term is just a variable. Sometimes your term is a number multiplied by a variable, right? So in this case, 6 I would call my coefficient. The coefficient is the numerical part of a term. Right? In this term, my coefficient is 1 over 7, right? It's what you're multiplied by. So it's 1 in the numerator, 7 in the denominator. If I had negative y, my coefficient would be negative 1. Okay, so it's what is being multiplied. Now, when you start to add and subtract terms together, that's a polynomial. Okay, so if I add and subtract these terms together, I am now talking about a polynomial. It is a term, a monomial, so a single term is a monomial, or the sum of terms, right? And when I say sum, it could also be difference, because whenever you're subtracting is the same as adding a negative, so you can always just make all subtraction adding, in which all the variables have whole number exponents, so whole number means 0, 1, 2, 3, ... and which variables appear only in the numerator, right? So if I had a variable in the denominator, well, we know a variable in the denominator, when we move that y to the top, the one exponent becomes negative, so it's no longer a whole number. So our variables have to be in the numerators, and our variables have to have whole number exponents. So a reminder, a monomial is a single-termed polynomial, a binomial is a two-termed polynomial, and a trinomial has 3 terms. Okay? And a reminder, a polynomial will have whole number exponents on the variables. Right? If I gave you 3 to the power of 2 or 3 to the power of negative 2, which is 1 over 9, I don't really care about the exponents on my numerical part because they can be evaluated. I just care on the variable. The variable cannot be rooted. Okay, if I have an x under the root sign, that is actually x to the power of 1/2. You'll learn more about that in grade 11, so that is not a whole number. Therefore, x cannot be rooted, and the variables are only in the numerator. Okay, so let's practice. Let's look at these 4 and determine if they are polynomials. So let's look at the first one. So the x has a power of 2, that's okay. This x is not under the root. The coefficient is root 2, that's okay. But the x has an exponent 1, so that's okay. So this is a polynomial, and more specifically, because there's 3 terms, right? Think of like a train separated by plus and minus signs. There's 3 terms. This is a trinomial. Over here, I can see that y is in the denominator, so right away I say, nope, not a polynomial. Again, over here, my exponent on my variable is negative, so not a polynomial. And over here, my x is under the root sign, right? So in front here, the x was outside of it, but over here it's under. So because x is being rooted, it is not a polynomial. The degree of a polynomial. The degree of the polynomial, so let's just start with a monomial, a single term. It's the sum of the exponents of the variables. So if there's only one variable, it's the exponent. The degree is 4, right? The degree of a polynomial helps determine when we graph it its shape. So a lot of times we like to discuss the degree because it gives us information on what type of shape we're talking about in our graph. Since there's 2 variables, x times y squared, you take the sum of the exponents. So the x has an exponent 1, the y has an exponent 2, so we're going to take the sum and get a degree 3. When you have a polynomial that's not a monomial, so in this case I have a trinomial, you just take the degree of each term, and whichever one is highest, that's the degree of the whole polynomial. So in this term, it's 4. In this term, it's 5. In this term, it's 2. So the highest is 5. Another word we should make sure we understand is the word constant term. The constant term has degree 0, right? Or it's the term without a variable. Because, why does it have degree 0? Because any variable to the power of 0 is just 1, right? So it gets rid of the variable. So in this case, my constant term, it's not 4, it's actually negative 4. Whenever you have these polynomials, I always like to think of it as everything is adding, right? So whenever you have a subtraction, you could always rewrite it as adding, the opposite. Therefore, the constant is a negative. Or instead of rewriting it, I just take the sign in front and always attach it to the term that follows. This term is negative 4, right? This term is positive 2xy. All right, so now we know the degree. We should also understand what descending order is. Whenever I write my answers, I always typically write it in either ascending, going up to the greatest power, or descending, going from the greatest to the lowest. So if I want to rearrange this, remember what I said, the sign in front goes with the term. So this is negative 5x squared. And then I'm going to write this one, positive 25x, and then I'm going to write this one, so there's no sign in front, it's positive 4. So this is descending order, the highest degree down to the lowest degree. We should remember how to add polynomials. Okay, adding polynomials is when you have a plus sign between. And when you're adding polynomials, the brackets are for grouping, right? Inside the brackets, I can't collect like terms because they are not like terms. So when you're adding polynomials, you can just ignore those brackets and collect like terms. The brackets are not operational. They're just grouping. Okay, so I ignore the brackets and I collect like terms. When I collect like terms, I always collect them in the order of the alphabet. X, then Y, then constants always last, because then it matches your answers and it's easy to check your answers. So 5x minus 8x is negative 3x, right? The number in front, the coefficient, just tells you how many x's you have being added together. 5x is the same as x plus x plus x plus x plus x. So if you have 5x, it means you have 5 of them. So when you're taking away 8x's, you're going to end up with negative 3 of them, right? So that's what collecting like terms is. So now I have negative 2y plus 4y, so I get positive 2y, and then negative 3 and negative 7 is negative 10. If the signs are the same when you're adding, you keep the sign and add them. If the signs are different when you're adding, you take the difference and the greater sign, right? There's more positive, so my answer is positive, or there's more negative, so my answer is negative. And again, like terms, you have to have not only the same variable, but you have to have the same power. So 2x squared minus 6x squared is negative 4x squared. And I again collect like terms in descending powers. So the negative 5x doesn't go with anything, so it's still there. And then 4 and 9 is 13. So when you're collecting or when you're adding polynomials, you're just simply collecting like terms and you're ignoring the brackets. They are not operational. Subtracting polynomials, you have to be a little more careful because I'm not just subtracting the first term in the polynomial, I'm subtracting the whole polynomial. So what I like to do is a few things. Some people teach it as adding the opposite of every term, or I like to just put a little negative 1 in front and think of my distributive law. I'm going to distribute in a negative 1. That's going to give you negative x squared plus x minus 2. So once you distribute, whenever you use your distributive law, it makes your brackets disappear, and then you can just collect like terms. So if you ever have a subtraction in front of a bracket, you have to distribute in a negative 1. And so I'm going to continue on and just collect like terms. 5x squared minus x squared is 4x squared. Negative 2x plus x is negative 1x. I don't need to write the 1 coefficient. 9 minus 2 is positive 7. All right? So same thing here. I'm going to multiply in a negative 1. So I'm going to get minus 5 plus, and this is written yx. I always like to rewrite it so that the order is in alphabetical so I can easily find like terms. Again, when you multiply, order doesn't matter, so you can switch the order of multiplication anytime, and then you can see, oh yeah, those are like terms. So 3xy and 8xy is 11xy. -4 and -5 is -9. All right, so that's adding and subtracting polynomials. Now let's remember our good old distributive law, the one I just showed you, right? Again, a reminder, when you have a number in front multiplied by what's in brackets, the number has to get multiplied by both, right? Because if I had 2x plus 3, it means I have 2 of those added together. I have an x plus 3 plus an x plus 3, so that means I have 2 x's plus 6, or in other words, I have 2 x's plus 6, right? That's our distributive law. So I can multiply that into each term. So 5x times x. Now we're not adding, we're multiplying. That is not 6x, right? So when you're multiplying, you multiply 5 times 1, and then you multiply x times x. Be careful, right? We're switching between multiplying and adding here. You got to know which is which. Now I'm going to go 5x minus 3, and I'm going to get minus 15x. The distributive law will always eliminate the brackets, right? So whenever you apply the distributive law, the brackets go away because you've done the operation, you've done the multiplication, all right? Same thing here. We are multiplying. X squared times 2x is 2x cubed. We use our power laws. X squared times -3 is -3x squared. That is our distributive law. All right, I'm going to jump down to question D. Let's go right down to D here. Most people make this really common mistake. They go, oh, look, 5 plus 2 is 7, and then they distribute in the 7. But you have to be really careful because BEDMAS says, order of operations, you have to do your multiplication before you add. So because the 2 is squished next to the brackets, you must multiply first. And the 2 is positive, so you always take the sign in front. So I'm multiplying in the positive 2. This 5 just comes down for later. So that 5 is still there. Then positive 2 times x, then positive 2 times -2. Now that I've gotten rid of brackets, now I collect like terms. So now I have my 2x, and then 5 minus 4 is 1. All right? So same thing down here. I have to multiply before I do any adding or subtracting. Be careful. Take the sign in front with it. So the 9 comes down. The -8 gets multiplied by x. The -8 gets multiplied by -3, right? The 3 is negative as well, so you have to always watch that. A negative times a negative is a positive. Those little things matter. So I collect like terms. My x's first and my constants last. Okay, so that is our distributive law. Let's try one more. The last one. So I'm going to multiply in that 5x to get rid of the brackets. It only goes to what are in the brackets. It's squished next to it, so I can multiply. If it was 5x plus 3x squared minus x minus 2, see there's a plus sign there? Whenever there's a plus sign, there's like a hidden 1 there, right? So you're really just distributing in a 1, or in other words, your brackets just disappear. The brackets don't mean anything when there's a plus sign in front, okay? But since there's no plus sign in front, it means to multiply. So I get 15x cubed minus 5x squared minus 10x. That gets rid of the brackets. Again, here, it's not a plus sign, it's a subtraction sign, so it's like a -1. A subtract 1 is in front. So now I'm going to distribute that into the brackets. -1 times x, -1 times -4. Okay, you can see I have no brackets left in this step. Now I'm going to collect like terms in descending order. That one first. Then I'm going to do my x squared is -5x squared, and positive 4x squared is -1x squared. So I'm just going to write -x squared. And then -10x minus x is -11x. That is expanded. Right, so the first step was my expand step. Expand means use your distributive law and get rid of all your brackets. And then my simplify step means to collect like terms. So when I say expand and simplify, this is what I'm looking for. A final answer written in descending or perhaps ascending order with all like terms collected.